All right, so this is 13.1 still, and this is the application when you're trying to find area between two curves. So the application that we're going to use is what's called Lorenz curve and Gini index. So here's the basic premise of this. Now on your Canvas classroom, I do have a PowerPoint that kind of goes over the Lorenz curve and the Gini index, and it gives you, it breaks down like in the United States where Texas fits and where we are worldwide, that kind of thing. So the Lorenz curve is the visual, you can think of it this way, it's the visual, the actual curves of the representation, and then the Gini index is the value. So Gini index is how you calculate the percentage. The Lorenz curve is the graph of the percentage. So they really are the same thing. One's a visual, one's algebraically, okay? So the Gini index is always between 0 and 1. 0 is considered perfect equality, all right? Now, what that means is what we're looking at is how much is the income that is brought in by a country, how much is that income spread across the population? So what percentage of families? So for instance, if a certain family's income level is below 39,000 and the Gini index was 0.4, what that means is that 40% of the families with the income below 39,000 receive 11% of the income. So the X value represents the percentage of families at or below whatever the income is. The Y value represents the percentage of total family income received. Okay, so X is the percentage of families that have that value or have that income. The Y value is the percentage of total family income received. Okay, so again, if the X value is 0.4 and the Y value is 0.11, that means 40% of the families with income at or below 39,000 receive 11% of the income. Okay, so perfect equality means that all the income is shared equally across the families. All right. 1, because remember Gini index, so this is one of those indicators, your answers will always be between 0 and 1. So if you get close to 1, what that means is perfect inequality. So think of it this way. If your Gini index is 1, that means one person has all the income, everybody else is poor. Okay? So this does bring us to, you can get into politics on this, on what you think is fair or not fair. But if everybody shares equally, what they have found is that then nobody wants to put out an effort. Okay? If one person has all the income, then nobody else wants to even try because only one person has the income. So obviously you want to be somewhere in the middle, right? You want to have incentive for people to earn more money. You don't want everyone to have the same thing, but you also don't want one person bogarting all that's an old term, having all the income and everybody else is poor. So Gini index, you want to be somewhere in the middle, okay? All right, so where the area between the two curves happens is you have your perfect equality. So this is your y equals x function, okay? Then you have your Lorenz curve. Okay? What we're finding is the area between the perfect equality and the Lorenz curve. That's how the area between two curves comes into play into this particular application. All right, so let me give you an example and I'll walk you through it. So there is a formula that you have to use to find the Gini index and find the value. So let me give you the formula first. So the formula is, we are looking for values between 0 and 1. Remember, Gini index is between 0 and 1. And it is the area, it's let me redraw it. So it is your perfect equality, so y equals x, and the Lorenz curve. Okay, so remember we always subtract the upper minus the lower. So the upper is always going to be x in this case. And then we're going to subtract off whatever our function is, dx. And we're going to multiply this by 2. Now, where that 2 comes from is because if you remember, if I had that perfect inequality, right, is all of this, well, this is a triangle. So we are cutting it in half. So that's where the 2 comes from. So if I divided this whole thing, by a half, I flip it and multiply by 2. So this is the function to find the Gini index. This is the formula, this is how you find it, okay? So here's the scenario. Government of a small country is planning sweeping changes in the tax structure in order to provide a more equitable distribution of income. So in other words, if it's more equitable, right, we want it closer to 0. Okay, we don't want it closer to 1. We want our Gini index to be closer to 0. So the Lorenz curve for the current income distribution is f of x. So here's our Lorenz curve. F of x equals x raised to the 2.3. Determine the Gini index. All right? So here's our function. We're going to plug that into here. So our formula for finding the Gini index is 2 times evaluating the integral between 0 and 1. X is our perfect equality minus our function dx. Okay, so there's your definite integral. And all it is, the only difference between what we did before and what we're doing now is now at the end, at the very end, we're going to multiply this value by 2. All right, so don't forget this 2. I'm going to color it in or identify it so you don't forget it. All right, that's going to come in at the end. All right, so here we go. So we are finding the antiderivative of x minus x raised to the 2.3. So the antiderivative of x, it was 1, I add 1, and I divide by my new exponent. So it is 1/2 x squared. This one, same thing, I add 1 and divide by my new exponent. So I have 1 over 3.3 x to the 3 raised to the 3.3. And now I'm going to evaluate between 0 and 1. So it is, sorry for my dog, 1/2 times 1 squared minus 1 over 3.3 times 1 to the 3.3. So there is my first one, minus, Katie, no, 1/2 times 0 squared minus 1 over 3.3 times 0 to the 3.3. Okay. Now, the good news is when you multiply by 0, everything dumps to 0. So you don't even have to calculate that, right? Everything's going to go to 0. All you have to do is calculate here. So grab your trusty calculator, and you're going to go 1/2. So let me write it down. So 1 squared is 1. 1/2 times 1 is 1/2. 1 to the 3.3, and if you don't trust me, just plug it in, is 1. 1 to anything is always 1. So 1 times negative 1.33 is, negative 1.33. So all you have to do is 1/2 minus 1 over 3.3, and this gets 0.196969 and so on. But what'd you forget? Don't forget the 2. So you're going to multiply this answer times 2. So the Gini index, rounded to 2 places, is 0.39. So this is the Gini index. Okay? So we're going to hang on to this because we're going to compare the 2, because there's a second part to this. So we're going to compare the 2. So this Gini index is 0.39. It is closer to 0, which means it's pretty good as far if you believe that everybody should have equal income, right? It's not quite to 0, but it's closer to 0 than not. So now I'm going to save that. This is our Gini index for the first one. In fact, I'll write it over here. So the Gini index for this one is 0.39. Okay, so now we're going to test another one, get the Gini index of another one. Okay, so now the second one. So after the tax changes, the new function was 0.4x plus 0.6x squared. Okay, so this is before the tax enactment. Now we've made some tax changes, and so this is the new function, okay, income distribution. All right, so now we're going to do it again using this formula. So it's 2 times the integral between 0 and 1, x minus, don't forget your parentheses, 0.4x plus 0.6x squared. Distribute this negative through both. So you have x minus 0.4x minus 0.6x squared. So we're going to combine our like terms. So 1 minus 0.4 is 0.6. So we have our definite integral of 0.6x minus 0.6x squared dx. So now I'm going to find my antiderivative. So here's 1. I'm going to add 1, divide by my new exponent. So 0.6 divided by 2. I multiplied. 0.6 divided by 2 is 0.3. That makes sense. 0.3x squared minus, add 1, divide by my new exponent. So 0.6 divided by 3 is 0.2. So minus 0.2x to the third power. And now I'm going to evaluate between 1 and 0. Again, don't forget your 2. I always circle it because I always forget it. All right, so here we go. 0.3 times 1 squared minus 0.2 times 1 cubed. That's the first part. Subtracting off the second part when x is 0. And hopefully you have picked up on that it's just going to go to 0. 0 times anything is 0. So now all I have to do is calculate this. 0.3 times 1 squared is 0.3. 0.2 times 1 cubed is 0.2. So 0.3 minus 0.1 is 0.3 minus 0.2 is 0.1 minus 0. So now I'm going to take this. I know I'm running out of room. Erase this over here. And I'm going to multiply it by 2. Oh my gosh, 0.1. So 2 times 0.1 is 0.2. So this, the Gini index, is 0.2. So did the tax adjustments, did they help? Now, it depends on your views. If everybody should have equal income, then yes, it did improve it because it got closer to the value 0. If you don't believe that, and you think that there should be some incentive for people to do better by being able to earn money, capitalism, which is, where we're at, then I would say no, it's not better. So if it depends on what the question is. So in this particular one, the third question is, will the proposed changes provide a more equitable income distribution? So in this case, yes, it does provide a more equitable income distribution. But in my heart of hearts, I don't believe that that is a good thing. I think right now what we're experiencing is socialism because everybody is waiting for the government to step in and help them out. Okay, so that's my opinion. That's it, my opinion. Okay, so that is Gini index, Lorenz curve. There are 2 other applications in your My Math Lab. I'm going to wait and see how you do. It's just a matter of being able to set up the definite integral, know the 2 values that you're evaluating in between, and then just go from there. And I'll see if there's any questions on those. All right.